Let's continue with our proofs by contradiction. So here we are asked to prove that if x is rational, x is not equal to 0, and y is irrational, then xy is irrational. All right, so let's see here what we're required to prove. Okay, x is rational and y is irrational, then xy is irrational. Okay, so x is rational, so that's in our Q, it's an element of Q. Okay, y is irrational, so that's an element, not an element of Q, and xy is also not an element of Q. Now, contradiction, we're saying if x is rational and y is irrational, that's our P, then xy is irrational. So we're looking for P and not Q. Okay, so our proof by contradiction is suppose x is rational and y is irrational and xy is rational. Okay, and so that means that xy is going to be an element of Q. Okay, now if something is an element of the rational numbers, I can say that then xy can be written as a fraction because our rational numbers can be written as fractions. So let's make that P over Q, where P and Q are integers. Q can't equal 0 because then we're dividing by 0. And the greatest common divisor, that's what a GCD is, greatest common divisor. It's just a fancy way of saying it is completely simplified, of PQ is going to be 1. It's a simplified fraction. Okay. Now, we know that x is rational. We've said x is rational. So x can also be written as a fraction. So x can be written, and we're going to write different parameters so that we're not getting ourselves confused. So x is a over b. And again, a and b are integers. B can't equal 0. And their greatest common divisor is also equal to 1. Now, I can make this equation 1, 2, and I can substitute 2 into 1. So therefore, I can say, well, a over b times y is equal to p over q. Okay, so therefore y is going to be bp over aq. And multiples of integers are still integers. So multiples of integers are still integers. Now the weird thing about that then means that y must be rational. y is rational. But we said, that y is irrational. So there is a contradiction, as y can't be rational and irrational. So therefore my supposition is false. And so therefore, if x is rational and y is irrational, then xy is irrational.